Okay, let's continue on the practice 4 example. So now in this example, what you're going to see is how to find the equivalent impedance from this point A and B. So it's like your equivalent resistor, you're going to start from here. So before you can start the analysis, you need to change everything to become impedance. So let me redraw. So you have your inductor, this is a resistor, capacitor 10 microfarad, and then you have another resistor here. So for all resistor, it will remain the same, 8 and 3. And now you have 0.2H, right? So you know, let's say this is ZL is equal J. Now you need to know the omega. So the omega given here is 50 and your inductor is 0.2. So you can get here J10. So this is equal to J10. So just write here J10. So you have another two capacitors. So it becomes ZC1 is equal minus J. 1 over omega is 50 multiplied by 2 micro. So you can get here minus J10. So just write here minus J10, and then you have another one, ZC2 is equal minus J1 over 50 multiplied by 10 micro. You can get minus J2. So you just put here minus J2. This is 10. Okay. So this is step number 1. Always convert everything to become the phasor domain. So you're looking from here, what is the equivalent resistance? So slowly move to down. So here is again a capacitor minus J10. Okay, you can combine 3 and minus J2 are in series. Just make a box to become 3 minus J2. And this one inductor J10 and 8 are in series. So you just need to add. So become 8 plus J10. Okay, after that, so this is, for example, Z1. This is example Z2. So these are parallel, right? So what is the Z equivalent here? So let's say this is. So here is Z1 parallel to Z2. So how we can get that one is equal to 3 minus J2, 8 plus J, multiply together, divide by 3 minus J2 plus 8 plus J10. Okay, so then you just use your calculator. You got the equivalent parallel impedance. It becomes 3.22 minus J 1.07. So I hope you try this one by using your calculator. Okay, and finally, what is the equivalent resistance looking from here? This is minus J10. So you can get your equivalent is equal minus J10, and this component is in series, right? So you just add together minus J10 plus 3.22 minus J 1.07, and finally you can get 3.22 minus J. So this is not 1. Sorry, I missed some minus J. Yeah, correct. It's become 11.07. So this is the equivalent impedance of the circuit. So just leave your answer in the rectangular form and don't forget to put the unit, that is ohm. Okay. So again, how you are going to calculate the total impedance? Always change to the phasor form and then slowly move from this point towards the left point and find it either it is in series or in parallel. Okay. So let's see again this example. You will always given the 10 omega. So use this omega by changing this circuit slowly. So let's say the first one minus J 1 over 10, 0.5 microfarad. You can get here minus J 200. So just write here minus J 200. 80 will remain 80. And then you have here another one, ZC2 is minus J 1 over 10, 1 milli. And then you can get here minus J 100. So you just write here minus J 100. You will not use this value anymore. Now all in the complex. number. And finally, you have the inductor, is J omega L. So this one is become J80. This one remain 200. This one remain 80. So slowly just try to solve. 280 is in series, right? So means, and this one is in parallel. So let's say you want to find this point. So this one I just make it shortcut. You can do slowly. Is minus J100 parallel with 8 and 200. So just multiply 200 plus J80 divide by minus J100 plus 200 plus J80. So you can get the equivalent at this point. So how can you get the equivalent? So let's calculate this one first. You can get here around 49.52 minus J95.04. So what is Z equivalent? Impedance is equal to 80, and this minus J200 is in series, so you just add together. Minus J200, and this one also will be in series, right? So you also will add together. Minus J95.04, and then you can get the final answer is 129.52 minus J29.5. So I hope you will use your calculator, try to get either you get the same answer or not. So this is like a practice for you to familiarize yourself on how to use calculator using the complex number.